Hey guys, okay, welcome to this video again on practical electricity. Right now we're gonna just talk about some safety devices. Before we go into that, well, let's just look at this. I'm sure you've seen this around your home, but this is basically a 3-pin power socket. Okay, so what do we put in here? This is switch, 3 pins over here. Okay, so what do we put in here? We usually put this, right? So if you were to strip a power plug, you will see actually 3 cables inside. One of them will be the earth wire, the other one neutral. To the left and to the right, you actually have the live wire. Live wire is connected to a fuse. Okay, what are all these things? Okay, before we look into that, another view of a 3-pin plug will be this. So 3-pin plug, you have 3 of them will be earth, one of them live, another one will be neutral. Alright, having said this, I'm sure you've also seen this before, right? What is this? This is a 3-pin. This is a 2-pin plug. And what's a 2-pin plug? What do the 2 pins actually represent? They actually represent the connections to the live and the neutral wire. Oh, so the earth is gone in this case. Alright, so that brings us to the question, what are live and neutral wires? Okay, I'm sure you've got that right. So let's just dive straight into it. What is a live wire? What is a neutral wire? Okay, live wire, what is it? It's basically, live wire is at very high potential. Okay, and what does it do if it's at high? When it's at high potential, it actually delivers current to the appliance. What about a neutral wire? Okay, neutral wire is at zero potential. It just provides a return path for current. Okay, you can take this analogy to be, for example, like a working dam over here. It is a cross section of a dam. In the middle is your turbine. You can consider that as your actual appliance in the middle. Okay, for a dam to actually work, that means for the turbine to actually be moved, you actually need to have water at very high level and water at low level. Imagine if both waters are at the same level, you will not be able to get water flow. You cannot control that. So if you don't get water flow, you don't get your appliance don't move. Okay. So the one at high potential, you can consider it to be high potential energy. It's known as the live wire. This is the analogy over here. And the one at low potential, the one near the river, near the ground, is simply the neutral wire. Okay, so this is just an analogy. Okay, let's go straight into an example. What about the earth wire? I'm sure you'll ask me that. Okay, let's look at this. This is the working of a standard appliance. One of those things we use at home is the washing machine. Okay, you actually have your live wire here. It actually goes, connects to the motor, and then there's actually a return path, which is a neutral wire. So main supply means this is your 3-pin plug is over here connected to your main power circuit here, right? Okay, so in the normal case, this is what actually happens when you close the switch here. That means there's no break in contact. The large current will actually flow through the motor, moving the motor, hence moving the washing machine. Okay, but what happens after some time? What may happen to actually the internal wire? Okay, the internal wire may actually do what? You can see over here. Take a look here. Okay, just go back here. Look at this point here, right? What happens after some time? Due to wear and tear, the wire may actually be dislocated and an electrical fault may result in the live wire touching the metal casing of the washing machine. So what happens right now if it touches the metal casing? Remember this, the live wire? Live wire means it's high potential or high voltage, right? So if it's at high voltage, the entire metal casing now is at high voltage due to the electrical fault. So you see the high voltage is looking for a path to travel, looking for the lowest path. Just like your dam, water actually flows from a high position to a low position. So over here, since there's a fault here, okay, the entire washing machine is now live and it's looking for a low potential. And guess what happens next? All right, and booms, here you come along. When you touch the washing machine, you provide the return path of the high potential. That means the high current will actually travel through the washing machine, through you to the ground. Okay, so you provide, if a person touches metal casing, a large current flows through the person and you get an electric shock. So that brings us again to why do we need earthing? So this is a case where you do not have earthing wire. Okay, so with earthing wire, what actually happens? Okay, even though you have an electrical fault, what happens? Look at point number 2. The large current flows to the ground through the earth wire, goes through the earth wire here. So the earth wire has a much lower resistance than the person, therefore the person doesn't suffer electric shock. Okay, so when the flow of the high current from the live wire through the metal casing to the earth wire, which is the ground, it creates a short circuit. At the same time, the fuse is also blown, then the whole washing machine is not live anymore. Okay, so that's the main purpose of the earth wire. I hope you enjoyed this video. All right, see you again soon.